Good afternoon, it's Jeremy. It's Friday, November the 21st. This afternoon, I'd like to talk about saving files. Now, when I'm working with, let's say, Windows and SDR Sharp, you have two options there of saving files. You can save the raw IQ data baseband, and that saves into a WAV file with a left and a right channel, where the left is the I sample and the right is the Q sample, and it's saved at the sampling rate that you set for your receiver. Or you can save it as an audio file, which again will be a WAV file, and I think its default is 48 kilosamples per second. Now, if you're working with a Raspberry Pi 4B and you're using Gqrx, you have two options as well there. You can save the file IQ, or you can save it down here as an audio file. The audio file will be a WAV file with 48 kilosamples per second. But when you save it as an IQ file, it turns out to be similar to GNU radio, and it'll be a 64-bit file. So basically, every sample will be 64 bits, and the first 32 bits will be I, 32-bit float for I, and the next 32 bits will be 32-bit float for Q. Now, you can't, unfortunately, trim that with Audacity. Audacity is the program I've used to trim down my various files. So I'll give you an example here of what I want to do. I'm working on a DSC, VHF DSC decoder. So here's my reception from the other evening. Actually, it's November I think it's the 12th, around 1800 local time. And around 1800, there's 3 bursts. So what I do is I run I've saved the file here. I've got all my saved files here. I've saved WAV files, and I've saved IQ files as well. So I've opened one of the IQ files here, which is this one. Okay, so this is the file we want to look at. This is before I do my program and I clip it. So we'll find out that there's 3 bursts. The first burst occurs around 44 seconds into the file. The second burst is the strongest. It occurs around 54 seconds into the file. And the third burst occurs at around 1 minute, 3 seconds into the file. So let's play this and we'll see what happens. And we'll look at the clock down here. Okay, there's the first burst at 44 seconds. Coming up on the second burst. That's the second burst, that's the strongest. That's the one we want to trim. And that's the third burst. So what we want to do now is I have a Python program here which I've written. And let me just shut this thing off here. Okay, so there's the file opened in Tony. So basically what we do is we have, there's our data file, Gqrx, and that's all the metadata. And here's what we want to save it to. I'm going to give it the same name, _clip. So we use NumPy. We import NumPy as NP, and then we read in the data. So the IQ data will be equal to np.fromFile, and then you get the file name, and you put the data type. So we're going to be using 64-bit complex. So you got to put that in there, np.complex64. And here's the interesting part. We need a start index and a stop index for the trim data. So basically what the start index is, it's what sample do you start at. So let's say the data occurred around 54 seconds. So let's say I want to trim from 53 to 56 seconds. That's the data I'm interested in. So where do I get this number from? Well, if I take the sample rate, which is 240,000 samples per second, and I multiply that by 53 seconds, I get this, 12,720,000. And 56 seconds in times the sample rate is this number here. And that's the start index and the stop index. That'll trim your file. And that's where I want to save it to. So when I run that, incidentally, I save this file in the same directory as my Gqrx files here. So it's down there, and then basically I run it, and then I get the clip version of that file. So we can look at the clip version. The details are in the blog post, incidentally. So let's run Gqrx again. And we'll use the IQ recorder. And this time we'll select the clip file. And when I open that, you'll see instantly that we'll see the most powerful burst. So there we are.